there, my name is Tawfiq Omar Uthman, math teacher. In our video for today, I'll try to explain Chapter 4, Lesson 4, Curve Sketching, easily and step by step. Please be careful, there is a link for exercise of this lesson. Download it and use it carefully and correctly. Do not forget to subscribe the page and push the like button and write your comment if you have any. Let us start our lesson. Guidelines for analyzing the graph of the function. Determine the domain of the definition of this function. Determine the intercepts, asymptote, and symmetry of the graph. Locate the value of x for which f prime of x either is 0 or do not exist. Use these results to determine increasing, decreasing interval and local extrema. Locate the value of x for which f double prime either is 0 or do not exist. Use these results to determine concave, convex interval and inflection point. Collect this information in a table to use it. Sketch the graph of the function using this information. Example number 1. Sketch the graph of the function f of x is equal 2 times x squared minus 9 over x squared minus 4. First of all, find the domain of this function. To finding the domain of this function, take the denominator equal to 0 and find the value of x. By taking minus 4 from left to the right, we get that x squared is equal 4. And taking square root for both sides, we see that x is equal plus or minus 2. That means that the domain of this function is all real number except minus 2 and 2. And x equal, find asymptotes, and the x equal minus 2 and x equal 2 are vertical asymptotes. We draw these two vertical asymptote, x equal to minus 2 and x equal to the 2. Because the degree of the numerator is 2 and the degree of denominator is 2, that means the degree of the denominator is equal the degree of the numerator. Because of that, y is equal the leader coefficient of the numerator over the leader coefficient of the denominator, which equal 2 over 1. That means y is equal to is a horizontal asymptote. This is y equal to the horizontal asymptote. And now finding the intercepts. To finding the intercept, first of all, let x be equal to 0 and find y. Y is equal by replacing 0 at place of the x at the function. We can see f of 0 is equal 2 times 0 squared minus 9 over 0 squared minus 4. Become 2 times minus 9 is minus 18 and over minus 4 by cancelling or dividing minus 18 over minus 4 is 4.5 That means 0, 4.5 is, and now let y be equal to 0, then 2x squared minus 9 over x squared minus 4 is equal to 0. That means because this fraction is equaling to 0, that means the numerator is equal to 0. So 2x squared minus 9 is equal to 0. By dividing by 2, then x squared minus 9 equal to 0. By taking minus 9 from left to the right, then x squared is equal 9. By taking square root of both sides, then x is equal plus or minus 3. That means we have two horizontal intercepts. One of them is minus 3, 0, and the other one is 3, 0. Symmetric. Find f minus x, which equal 2 times minus x squared minus 9 over minus x squared minus 4. It equal, because minus x squared is x squared, so 2 times x squared minus 9 over x squared minus 4. As you can see, this is the value of the function. So it equal f of x. That means f of minus x is equal f of x. So fx is symmetric respected to y-axis. Or, first of all, without doing this one, we can say because the degree of the numerator is even and the degree of the denominator is even, that means the function of numerator and the function of denominator are even, so even dividing by even is an even function. Find the critical point. To finding the critical point, we must first of all find the value, the f prime of x. fx is equal 2 times x squared is 2x squared, 2 times 9 is 18, minus 18 over x squared minus 4. And now f prime of x is equal denominator x squared minus 4 times the derivative of the numerator, which means 2 times 2x is 4x, minus the derivative of 80 is 0, minus, and now the numerator 2x squared minus 18 times the derivative of the denominator, which is 2x. Simplifying this, it becomes f prime is equal 20x over x squared minus 4 over square. When we equaling the derivative to finding the critical point to the 0, we find that 20x is equal to 0. Every fraction, if it is equaling to 0, that means the numerator is 0. So x is equal 0. First, in the few steps before, we find when x is equal 0, y is equal 4.5, as you can see at the graph of the function. That means 4.5 is a critical point. F prime of x is equal 20x over x squared minus 4 over square. And now we have a critical point 0, 4.5 is a critical point. And now testing this point to find the intervals of increasing and decreasing. And now when f prime x is equal 0, f prime of x is 0. When x is equal minus 2 and 2, the derivative and the function are not defined. So in this interval from minus infinity to minus 2, the f prime is negative, because if we take any number smaller than minus 2, let be minus 3, and we replacing at the derivative, you can see minus 3 times 20 is minus 16, so it is negative. And from minus 2 to 0 is negative 2, because if we take minus 1, it's become minus 20. And now, if we take 1 is positive, that means increasing. If we take here 3 and replace it and place of x, it become increasing. That means decreasing, decreasing, increasing, and increasing too. So the decreasing interval is from minus infinity to the minus 2, and from minus 2 to the 0. And increasing interval is from 0 to 2, and from 2 to the positive infinity. And the point 4.5 is a minimum, local minimum. Find the concave and convex and inflection points. This is the first derivative, f prime of x is equal 20x over x squared minus 4 squared. And now take the second derivative. The second derivative, f double prime of x is equal the derivative of the numerator, which is 20, times the denominator, x squared minus 4 squared, minus the numerator, 20x, times derivative of the denominator, which is 2x squared minus 4 times 2x. Simplifying this, it becomes f double prime of x is equal minus 20, 4 plus x squared over x squared minus 4 to the power 3 is not equaling 0, because 4 plus 3x squared is not equal to 0. So there isn't any inflection point. To finding the interval of concave and convex, take the value of x minus infinity to the minus 2 and 2 to the positive infinity, and fx here is undefined, and at 2 is undefined, and f double prime is here is negative, because if we take any number, you can see smaller than minus 2, and replacing at the second derivative, you can see it become negative. For example, minus 3, if we put minus 3 here, minus 3 squared is 9 times 3 is 27, and plus 1 is 31. 31 times minus 20 is minus, and here that means the numerator is minus. And now minus 3 squared is 9, minus 4 is 5, 5 is positive, negative over positive is a negative. That means this interval is convex from minus infinity to the minus 2. And if we put here a 0, as you can see, it becomes positive, the value of double prime fx, it becomes a concave interval, and here is convex too. That means the function is concave. Convex interval is from minus infinity to the minus 2, and from 2 to the positive infinity, and concave interval is minus 2, 2. If we draw the graph of the function, as you can see, the function here at interval from minus infinity to the minus 2 is decreasing and convex, like this. Decreasing and convex. But at interval from -2 to 2, the function, first of all, from -2 to the 0, the function is decreasing, but it is concave, like this. Decreasing, but concave. And at the 0 to the 2, the function is increasing, but concave, like this. And the function at 2 to the positive infinity is increasing and convex, like this. This is the graph of the function f of x. Example number 2. A. Use the graph of the function f of x is equal x squared minus 2x plus 4 over x minus 2 and find the domain of the function. In the exam, it not give you the equation of the function, but only gives you a graph of the function. To finding the domain, we are searching for the vertical asymptote. As you can see here at the graph of the function, we have a vertical asymptote at x equal to 2. That means this function is defined at all real number except 2. That means B is a correct answer. R except 2. This is the domain of this function. But if the equation is given to finding the domain, take the denominator and equal it to 0. It becomes x minus 2 is equal to 0. That means x is equal to 0. So the domain is all real number except 2. B. Use the graph of the function f of x is equal x squared minus 2x plus 4 over x minus 2 and determine the intercept of the fx. If the graph is given, as you can see here, as you can see, this part is not intersecting with the y-axis and x-axis. But this part is intersection with the y-axis at 0 minus 2. At 0 minus 2. This is 0, x is 0, and y is minus 2. That means A is a correct answer. A, 0 minus 2 is an intercepting of this function with the y-axis or vertical intercept. But to finding the intercept using the equation of this function, first of all, let x be equal to 0 and find y. F of 0 is 0 squared minus 2 times 0 plus 4 over 0 minus 2. It becomes minus 2 because here remain only 4 and here minus 2. 4 divided by minus 2 is minus 2. That means 0 minus 2 is a vertical intercept. To finding the horizontal intercepts, y is equal, let yx be equal to 0 and take the fraction x squared minus 2x plus 4 over x minus 2 is equal to 0. By crossing multiplication, you can see x squared minus 2x plus 4 is equal to 0. And now, using the rule b squared minus 4ac, it becomes minus 2 because b is minus 2 and a is 1 and c is 4. So, minus 2 squared minus 4 times 1 times 4 is equal minus 12 less than 0, that means this equation is not equaling to the 0. So there isn't any horizontal intercepts. And now use the graph of the function f of x is equal x squared minus 2x plus 4 over x minus 2. Determine the asymptotes of the function f. As you can see at the graph of the function, you have two asymptotes. One of them is vertical and the second one is the vertical asymptote is at x equal to 2. At x equal to 2. So x equal to 2 is vertical asymptote. There isn't any horizontal asymptote, but we have a slant asymptote. To finding the slant of asymptote, we have two ways. The first of all, we can start moving from the point, any point on the line or at the asymptote. I started from 0 and move it 4 units to the right. So that means delta x is equal to 4. At the end of this moving, I'll try to go up, moving to the up until reaching the line. As you can see, we are moving to 2, that means 4, that means delta y is equal to 4. And now m, that means the slope of the line is equal delta y over delta x, that means 4 over 4 is equal 1. And now because the line or the slant asymptote is passing through the 0, 0, that means b is equal to 0. So the y is equal mx plus b is equal y is equal 1x plus 0, so y is equal to x. This is the first way to finding the slant asymptote. The second way, we can do it in another way. We can take 2 points over any 2 points over the slant asymptote. Any 2 points. That means if we take 0, 0, because the line is passing 0, 0, and 2, 2, and 4, 4, and 6, 6, and 8, 8, that means y is equal x is the equation of this function. But we are going to use this point to these 2 points to find the slope of this line. The slope of this line is equal y2 minus y1 over x2 minus x1, which means 4 minus 0 over 4 minus 0, which is equal 1. And using the formula, slope point y minus y1 is equal mx minus x1, and y minus 0 equal 1x minus 0, that means y is equal 0, x is a slant asymptote, or the equation of the slant asymptote. As we said, the B is a correct choosing. And now, in which interval the f is increasing, as you can see here. First of all, we must find the intervals. The first interval is from minus infinity to the 0, and the second one is from 0 to the 2, and the third one is from 2 to the 4, and the fourth one is from 4 to the positive infinity. That is the intervals. And now, as you can see, at interval from minus infinity to the 0, the function is increasing. And from 0 to the 2, the function is decreasing. From 2 to the 4, the function is decreasing. And from 4 to the positive infinity, the function is increasing too. That means the increasing interval is from minus infinity to the 0 and from 4 to the positive infinity. And the decreasing interval is from 0 to 2 and 2 to the 4. That means the f is increasing at minus infinity, 0, 4 plus positive infinity. Use the graph of the function and find the local extrema. As you can see here, we have two local extrema, one here and the second one is here. Here is at 0 minus 2, it is a local maximum, and here you have a local minimum. That means local maximum is 0 minus 2 and local minimum is 4, 6. As you can see, local minimum is 4, 6 and local maximum 0 minus 2 is at C is a correct answer. Example number 3. Use the graph of the function to answer the question below. Question number 1. In which value of x, fx has the local maximum? We know that the function has a local maximum if the derivative, the first derivative, is equal to 0 or undefined or not exist. As you can see at the graph of the function here, we have here a local maximum because function is increasing, after that decreasing. So to finding the value of x from this point, which is local maximum, draw a vertical vector over x-axis like this. As you can see, it's become x is equal minus 1. That means when x is equal minus 1, the function f of x has a local maximum. That means C is a correct answer. The second question, in which interval f prime of x smaller than 0, that means negative. The f prime of x is negative is at interval of decreasing, when the function f of x is decreasing. F prime of x less than 0 if fx is decreasing. As you can see, we have two local maximum and local minimum, and we have 4 intervals, one of them from minus infinity to minus 1, and the second one from minus 1 to 1, and from 1 to the positive infinity. As you can see at the graph of the function, the function f of x increasing at interval minus 1, 1. So f prime of x is less than 0 at interval minus 1, 1. That means A is a correct answer. Question number 3. In which value of x f double prime of x is equal to 0? F double prime of x is equal to 0 at inflection point, which is x equal to 0. As you can see, we have an inflection point here. So inflection point, because this is an inflection point, so f double prime is 0. Question number 4. In which interval f double prime is bigger than 0? F double prime is bigger than 0, that means it is positive at a concave interval. As you can see, the graph of the function f of x is concave at interval from 0 to the positive infinity. from 0 to the positive infinity. That means f double prime is bigger than 0 or positive at interval 0 positive infinity. Question number 5. The statement f minus 2 equal f2 is true or false? If it is false, correct it. As you can see that this function is symmetry respected to the origin point, because the graph which is at the quarter 3 is same as the graph at the first quarter, and the part of the graph at the second square is the same as the graph of the function at the fourth quarter. So fx is symmetric respected to the origin. Because fx is symmetric respected to the origin, so f minus x is equal minus f of x. If we replace it 2 in place of x, it becomes f minus 2 is equal minus f of 2. As you can see that this statement is not correct because there isn't any minus here. So it is false. And this is the correct. Question number 6. F prime of 1 is equal f prime of minus 1. This is x equal to minus 1. If we draw at x equal the minus 1, the tangent line at the 1 f prime of x, because the tangent line is parallel with the x-axis, that means the slope is 0. Because the slope is 0, so f prime at 1 is equal to 0. And the same thing, as you can see, the tangent line is parallel to the x-axis, so the f prime is equal to 0. That means the slope is 0. In another way, we can say, because the tangent line at x equal minus 1 and the tangent line at the x equal to 1 are parallel, that means their slope is equal. Because every two parallel line, their slope is equal. So f prime of 1 is equal f prime of minus 1. That means the statement is true. Here we reached end of the lesson. Thank you for watching. Please do not forget to subscribe the page and write your comment, and if you have any question, push the like button. I will remember you that there is a link for exercise of lesson. Download at the description. Download it if you need it. And thank you for watching again, and goodbye.